This is my Algebra 1 video that discusses one-step inequalities with addition and subtraction, and this is part 2 of a two-part series. But before we start, I want to go over a few things. The first thing is that whatever you do on one side of the inequality, you must do on the other side of that inequality. And once again, if you're asking yourself, what is an inequality? It is a mathematical sentence that has either a greater than, a less than, greater than or equal to, or less than or equal to sign in it. Here's an example. It is greater than or equal to. 7 is greater than or equal to 7. This is true. But if I subtract 3 from this side and do nothing to the other side, I have 4 is greater than or equal to 7. And this is not true because 4 is neither greater than or equal to 7. So if I'm going to subtract 3 from this side, I must also subtract 3 from this side in order to keep the equation true. Another thing before we start, additive inverses. Positive 1 and negative 1 are additive inverses of each other. That is because when you combine them, the result is 0. The rule is when added, additive inverses will equal 0. Here are some examples of additive inverses. What do I need to add to negative 6/5 to equal 0? Well, I need to add positive 6/5, right? That is because negative 6/5 and positive 6/5 are additive inverses of each other. Here's another example. What do I need to add to 12 to equal 0? Well, I just need to add negative 12. That is because positive 12 and negative 12 are additive inverses of each other. Now, we're going to solve a one-step inequality that uses addition and subtraction. Here we go. X minus 3 is less than or equal to 5. This is an inequality because it has a less than or equal sign in it. So we draw our line, we have x, then we have our negative 3, right? And we bring our sign down, and on this side, this is a positive 5, right? So we have a positive 5. Now, let's try to solve this. X minus 3 is less than or equal to 5, right? So we got our minus 3 once again, and we have our positive 5. Now we want to get rid of this negative 3, so we have the x by itself, correct? So then we would just add the additive inverse of negative 3, which is positive 3, correct? And then that cancels out, or it ends up with negative 3 plus 3 is 0. So you would have x plus 0 or just x. Now, whatever I do on this side of the inequality, I must also do on the other side of the inequality, right? So I had 3 positive 1s, and I got to put that on this side too. So now that leaves me with x is less than or equal to 1, 2, 3, 4, 5, 6, 7, 8. X is less than or equal to 8. Let's see. X is less than or equal to 8. This is our original equation. This is our solution. Plug in x is less than or equal to 8 for x. And there we have x minus, in this case we can use the number because it is less than or equal to. So we have 8 minus 3 is less than or equal to 5. That is true because this side equals 5 and this side equals 5, correct? Let's try a number that's less than 8. 7 minus 3 is 4. And is 4 less than or equal to 5? Yes, it is. Well, let's try a number that's greater than 8. 9. 9 minus 3 is 6. Is 6 less than or equal to 5? No, it is not. Once again, we're going to graph our solution on the number line. This time, this is our solution right here. X is less than or equal to 8, correct? We're going to draw the circle and we're going to fill it in because now we're including 8. If we were not including 8, then we would not fill it in. Then we will draw a line for all those numbers that are less than 8. So when you fill it in, you're including 8, and then you draw a number line that includes all those numbers that are less than 8. Now, this is our equation again, but this time we're going to use the inverse operation in order to get the variable by itself, correct? So we are subtracting 3 from x. So the inverse operation of addition is subtraction, and the inverse operation of subtraction is addition, right? So we're subtracting 3, we're going to add 3. You have to do that to both sides. Negative 3 and positive 3 cancel each other out. We're left with x. X is less than or equal to 5 plus 3, which is 8. And that is what we had before. Things to remember when working with one-step equations that use addition and subtraction is that you want to get the variable on one side of the equation and the numbers on the other side of the equation. Also, in algebra, it's really important to know that whatever you do on one side of the equation, you must do, or inequality, you must do on the other side of the inequality. Also, additive inverses of each other will equal 0 when added, and an inverse operation of addition is subtraction, and the inverse operation of subtraction is addition. Things to remember about graphing an inequality. Here we have our number line. This is our solution. X is greater than or equal to negative 5. Okay? So now we're going to take a circle where negative 5 is, and since we're including 5 because it's greater than or equal to 5 would be including it, we would fill in that circle, and then we would draw an arrow for all those numbers that are greater than negative 5. So you remember to fill in the circle when the answer includes a greater, less than or equal to, or greater than or equal to sign in the solution. This has been an Algebra 1 video that discusses one-step inequalities with addition and subtraction. This has been part 2 of a 2-part series. You can reach me, R. Jansen, at jansonmath620@gmail.com.